Okay, perfect. Typically, I have a bad habit of walking back and forth, but lack of clicker make me cement here. So that might be a good thing or a bad thing. So what you see on the screen is a post from Changpeng Zhao, the CEO of world's largest cryptocurrency trading platform. He goes by the name CZ. So what CZ is referring to is one of the largest data breach in terms of number of people affected. In the summer of last year, a national police database of a certain country was leaked. This database contained many terabytes of information on 1 billion citizens. Now, CZ's post came in 4 days after the hacker posted. Now, the hacker offered to sell the lot for 10 bitcoins, roughly $200,000 at that time. A reporter from Wall Street Journal verified that the leak is actually correct because she started calling people from that leaked information and people started picking up. And they were, of course, terrified because a reporter is calling and telling them all of their data is now publicly available. Now, if you think that you and your organization are safe from such breach, I'll welcome you to check out this website, which wonderfully visualizes large data breaches across the globe. Now, my goal in this session, who's managing the credentials for your database, is to provide you the information and necessary tools so you can avoid such data breach. My name is Dewan. I'm from the beautiful New Brunswick, which is in the east coast of Canada. If you haven't visited New Brunswick, please visit, especially in the summer, it's beautiful. I work as a developer advocate at Ivan. Most people don't know what's a developer advocate and why we get paid. So if you have the similar question after the talk, please reach out and I'll explain what developer advocacy is. For the last 10 years, I've been focusing mostly on application and data infrastructure. So that means Docker, Kubernetes, secret managements, all those fancy buzzwords. And in my free time, I'm a pro bono career coach. That means I help students and new grads to get started in a career in tech. So in my weekends and evenings, I've been doing resume reviews. I've done more than 1,000 resume reviews. If you know any student or anyone you know who would like a free resume review, those are my LinkedIn handles and my Twitter handles. I'll also appreciate if you would like to take a photo sometimes, tweet, everything would be appreciated. All right, so what's the agenda of today's session? So we'll talk about database security, but database security can be massive, right? So it can be from physical access. That means someone can just run away with the disks and there's very little you can do, right? Now, your database is typically running in some sort of bare metal physical machine or some virtual machines. If someone captures that host machine, again, your database might be compromised. Next, you can have SQL injection attacks from your client running some malicious SQL codes, and that can do some unintentional read or even some administration commands, which is not intentional. Now, this is the 3 things can result in a data loss and data backup. And of course, your clients would not appreciate if you lose their data. But today, I will not be talking about any 4 of these. I'll be talking about database access. And the reason is 80% of or more data breaches result from poor or reused passwords. All right, so this is the agenda. We might have seen this or not, or we might not want to acknowledge if we have seen this or not, but this is far too common. So we have a password and it just gets shared around, right? So at the first half or first quarter of the session, I'll talk about the problem with database access. And of course, just like a good speaker, I'll not leave you with the problem. I'll also talk about the solution, which is dynamic credentials. Then I'll talk about choosing the right tool because we all know it's 2023 and we don't have any shortage of tools. And finally, there'll be a demo because it's a technical conference. We all are here for the demos. All right. So what do I mean by database access? So from the network security model, it's a pretty well-known AAA threat model. The first A is authentication. Who can access your resource? The second A is for authorization. Someone can access, but what they can or can't do, the ACL, access control list. And the third A is for auditing. Someone accessed, someone did some commands. After 1 week or 1 month, you want to go back and see what was done. Or maybe this is part of your auditing report, like this is compliance, that you have to manage an auditing trail. So these are the 3 A's I'll focus on during the theoretical part and also during the demo. By raise of hands, who have heard of Shodan? All right, cool, few people. So Shodan is a search engine, but this targets internet-connected devices and services. So a user can use Shodan to find out servers, printers, databases, everything that is publicly accessible. Now, from my hotel room last night, I took this screenshot. And this shows that still there are roughly 800,000 PostgreSQL instances globally that are publicly accessible. Now, you can imagine what a malicious user can do with this information. They can do a lot of exploitation techniques. The first one is, a lot of time, more than we can imagine, administrators using are using the default credentials. So they have the URL, the host name, the port number, and they're just using the default credentials to log in, plain and simple. The next one is vulnerability exploitation. So you might not have upgraded to the latest version, and the hacker already knows all the exploitations of the previous versions. They're targeting specifically from that search query. They can even query like which version from the list, and they're targeting those versions to exploit. Then the misconfigurations. Now, there can be a lot of misconfigurations, but one of the most common one is having your database publicly accessible. So typically, we want our applications to talk to the database, not a random stranger on the internet. So that's why we do like a VPN, public gateway, only to restrict that IP address or host name of my application, not open it for everyone. But that's what misconfigurations do. All right, what are the other issues with database access? So it's something called secret sprawl. And that means we have secrets everywhere. Some continuous integration server running, and that has our database credentials. Maybe that employee left 6 months ago and wasn't happy with something, and they have the credentials, right? So we have passwords everywhere. Then we have companies saying that we're going to roll it on our own. Cryptography, not a problem. Encryption as a service, not a problem. We're going to roll it on our own, even though that is not your business expertise. That can cause a lot of messes. And then we have the same database password forever. So that's what the meme talked about, right? Like it's a shared password, but you just don't change it. Or even if you change it, it's by the year or by some numbers. And machines have evolved. So there is a website called security.org, and you can test your password strength. If you put your password, it'll show you like how long would it take for a typical machine to crack that open. So it can be deadly. Like, have you heard about the correct horse battery staple? Like that, how, so rather than the websites showing that you have to use an uppercase, lowercase, special characters, rather than that, you can use just dictionary words, but it's the length that matters. So it increases the entropy of the password, which is like the strength of the password. All right. The other thing is applications are very, very bad at holding secrets. As soon as you have your secret in your application, it pops it up to syslogs, some other sort of logs, and then you have your passwords in plain text. So with these problems, now we come into the part where we talk about solutions. How can someone take advantage of your password if the password never existed? So that's what we're talking about, dynamic credentials. So dynamic credentials are something that are generated on demand. It did not exist before. And this has a time-bound access. Now imagine you have a developer studying in Amsterdam and they work for 8 hours. So does it make sense to give them a password that is valid for a year? Probably not. They start their day, they request the password, it's valid for 8 hours, they finish their work day, the password is already revoked. Now imagine another scenario. You have one application that runs as a cron job and it periodically connects and polls the database, but it only needs the database access for a few seconds. Now, would you grant this application 8 hours of access? Probably not. Probably you just want a few minutes of access. Now, does it make sense to use the same credentials for both your human users and your applications? If you do that, how can you do auditing? In your audit log, it's going to be the same thing. Yes, the IP address might be different, but again, like the authentication, the identity would be same. So that's why with dynamic credentials, you can generate passwords for specific identity, your application, your human users, and for time bound. And that can be audited. So coming to the third part of the presentation, which is choosing the right tool. And we know that we don't feel the problem of lack of tools or lack of options. Nowadays, we feel the problem of too many options. Ask someone, hey, what kind of secret management tool we can use? Oh, this is PGCon, okay. What kind of database can I use? And you'll have 100 people lining up telling you about their opinion of why that database is the right choice. So we don't feel the lack of choice, but there's too many choices. So here are some considerations or some factors to consider when you're choosing the right secret management tool. The first point is about flexibility, because we know that as developers, we want flexibility. Sometimes we are using an SDK, sometimes you're using CLI, sometimes we're just using the UI to interact with the tool. So the tool should have all this flexibility. Now, we store credentials for our databases. Sometimes we're using AWS, Azure, a platform like Ivan, different platform. So that's why it's essential to have different integrations and providers. Encryption as a service, which I mentioned before. So you want the tool to handle data encryption and not write custom logic for that. You also would want the tokens to automatically expire after a given time frame rather than you have to manually expire those tokens. And then, in case of an emergency, if you find out there's a breach, you'd want to revoke certain passwords. And you want, if the password generates other child passwords, you want all of them to be revoked. So with these in mind, I'm proposing HashiCorp Vault. So what is HashiCorp Vault? So it's like a Swiss Army knife. So HashiCorp Vault started at the company HashiCorp as an open source project and still is an open source project. And it touches upon all those points I mentioned. As a developer, you can interact with Vault using the HTTP API, CLI, there's a UI, and there's a lot of SDKs to interact with Vault. There's a lot of different providers, whether you're using AWS, Azure, different cloud providers for different database backends. HashiCorp Vault can store short-lived credentials. It can generate short-lived credentials, but also it can store long-lived credentials. With Vault, you can even, if you have experience of generating X509 certificates yourself, you know how much the pain is for managing your own CA certificates. So Vault can be used as an intermediate CA or certificate authority or a root certificate authority. One of the points I highlight is Vault, unlike many of the newer open source projects, it has been there for some time and it has been battle tested in production by giant corporations and banks and insurances. And even the open source version of Vault have high availability. You can run Vault server as high availability mode. So let's think that if we didn't have a secret management tool, how would the scenario look like? So as a user or an application, I'd say, here's my static database password. The database would say, sure, you got access, and here is the data. Now let's look at if we have something like Vault. It doesn't have to be Vault, but something like Vault in the middle. So the first step is you have to authenticate to Vault. So once you authenticate to Vault, Vault verifies your identity. It would verify that credentials with the database, or it could be a cloud provider as well. And you, as a Vault administrator, you'd set some ACL or access control list for the authorization part, what this user or application can and can't do. Based on those ACLs, Vault would generate the dynamic credentials to the user or the application. Then you use the dynamic credentials to connect to the database. That credentials, again, is short-lived, generated on demand, and can be audited. So before I start the demo piece, we don't need to learn about the entire architecture. I'm going to touch about some specific pieces that will help us understand the demo. So this is the Vault architecture, and there's a clear separation of boundaries here. So you see the barrier. So everything outside of the barrier is untrusted. That means the HTTP API and the storage backend is untrusted. And the data that Vault writes to the storage backend is encrypted. That's why even if a malicious user gets access to the storage backend, that could be any database, your data is still encrypted. So think of just like a bank vault. So if the vault is sealed, you can't do much. You have to open the vault in order to go and access your money. Similarly, Vault initially is sealed. You can't do anything unless the vault is unsealed. And there's an algorithm they use. We're not going to go into that. Shamir's secret sharing algorithm, where multiple people have to come together with their keys in order to open the vault. Once the vault is open, then your applications and users can authenticate to Vault. They authenticate and they get a token. Every request is associated with a token. And then we have different secret engines. If you see at the bottom of the screen, there's different secret engines. And in today's demo, we'll use a database secret engine. All right, demo time. So let's check out the demo. So I'm using a platform called Ivan. So that's the company I work at. So this is a trusted open source data platform. What I mean by that is we provide a data platform where you can create and manage services like PostgreSQL, OpenSearch, Kafka. All of the projects are open source themselves. If you'd like to know more about that, check with me after the demo. But this doesn't have to be running on Ivan. You can just use PostgreSQL on a Docker container. At the end of my talk, I'll give you a link to a GitHub repository and a blog which has all the information. Everything you can run either using Ivan, we have a free service, or you can use a Docker container. All right, so let's get started. So here I logged into the platform and I'm choosing PostgreSQL. I can pick any cloud provider. I don't have to be an AWS expert. I don't have to be a Google Cloud expert. So this creates a nice, simple abstraction. So I'm choosing a plan. Plan tells me how beefy the machine is, like your CPU, your memory. I'm giving it a name, and as simple, within a few simple steps, I create my PostgreSQL service. The blinking blue indicates that my service is still being provisioned, and I can already see my connection information, the service URI, my host name, port name. I can't yet connect to it because the service has to be up and running. So I fast forwarded the service creation. So you can see the blinking is getting faster. Once it's solid green, that means that's when the service is running. All right, so now my service is up and running. So what I'll do is I'll connect to the service using the admin credentials. And the story for today's demo is we have an application that should access a table that is a public table, like a marketing table, but there is a sensitive employee salary table, which it should not access. So that's what we'll show, how we can use Vault to achieve that. But before we can do much, we have to populate this database with some data. So that's why I'm creating the first table, which is the weekly matrix reporting. So imagine this is like a marketing organization table. So we have the product downloads, GitHub stars, Twitter followers, all of these are public information. So it's okay for my table application to access that. But the employee salary, that has employee salary information. So my application should not be able to access that. So now that I created these two tables, I'm gonna add just some sample data to all these tables. So I inserted 3 rows into the weekly matrix reporting table. And next, I'm inserting 3 rows into the employee salary table. So now I'm starting Vault server. So on my local machine, Vault server-dev, that starts the server. Now, this is the development version. So it says that it should not be used in production, because in production, you have the sealing process, the unsealing process, a much safer way of running it. But for demo purposes, I'm just running Vault server in development mode. I have to export Vault address and a root token. So root token, imagine that as a master password. You can do anything and everything using that root token. And then I have to tell my terminal where my Vault server is running. That's why I have to export Vault address, the line 6 lines above from the bottom. So on a separate terminal, I'll do that. All right, now my terminal knows where the Vault server is running. Now, this is the service password for my running PostgreSQL service, and this is already invalid because this is a recorded demo. There are only few steps. The first step is I'm enabling a secret engine, Vault secrets enable database. So this is the database engine. Now that we have the secret engine enabled, we have to configure that engine. By configure, I'm using a plugin, which is PostgreSQL database plugin. I can give it any name. I gave it Ivan for PostgreSQL. I'm creating a role, which is matrix-read and write. Now the username and password, these are in template. I'm passing the actual username and passwords underneath. That's because it doesn't show up in logs if I use it in a templated version. All right, so step 1, enable the database backend. Step 2, I configured the backend with my connection information. Step 3 is the role I created, metrics read and write role. Now I'm telling Vault what you can and can't do on the database. So I'm telling that you can use this creation statement, grant all only on the weekly matrix reporting table to the name being whichever name we created before for the role. It has a default TTL, time to live, for 1 hour. We can extend this credential up to 24 hours. That's it. With these 3 simple steps, now I generated a dynamic credential. This is actually a valid credential for my PostgreSQL database. So you can see the username at the bottom of the screen, the vroot a long name. You can configure that to match any specific format you want. You might wonder, hey, Dewan, like, how can I use that from a programming language perspective? I use a curl command as well. So as long as your programming language can make a HTTP call, you can use Vault. So now, besides the CLI command, I use curl to generate one more dynamic credential. All right, cool. So now that we have these 2 dynamic credentials created, time to start the test. By test, I mean, can we read those 2 tables or not? The first step would be, let's connect to the database using the admin credential. So I'll use the same pSQL client to connect. I'm still using the admin credential. Avian admin is the admin credential. And I'll see that if I can read both tables. All right, so I'm connected to the default DB, which is the name of the database. The first one is I'll read the weekly matrix reporting. Sure, I should be able to read it. That's the public table. The second one is I'm trying to read the employee salary table. I can read it because I'm the admin. All right, now let's disconnect. And now would be the moment of truth. Now we'll be using that dynamic credential to connect to the database. So we already checked we're now checking the authentication and authorization of the AAA threat model, these 2 A's. So let's copy the password. So this is the password for the username, vroot. And the database is default database, default DB. And the password is this password. All right, so the authentication part worked. That means using the dynamic credentials, we were able to connect to the database. Now comes to test the authorization. Can I read weekly matrix reporting? Yes, I can, because I granted access to this. Can I read employee salary table? I cannot, permission denied. So that shows that dynamic credential is working from the authorization point. Cool. So we tested the first A, the authentication, the second A, authorization. Now we'll see how we can use Vault to test the auditing. Who did what in your database? So now we're enabling the audit engine, Vault Audit Enable, and you can give any path. You can enable multiple audit devices. All right, so it was enabled at this path, Vault Audit 1, and I'm going to read that audit file. Nothing's there because since we enabled the audit, nothing happened. Let's make something happen. Let's request one more dynamic credentials. So Vault read, and now we got another dynamic credential. Because there was a request response, now we can see the audit log that there are some activity. You can see that the data part, username and password, they're hashed. That's because you don't want an actual valid username and password in plain text. But you might ask that, hey, Dewan, like, I don't make any sense out of that username and password. I suspect that my application or my employee did something wrong. How do I match them with this data? So you can use Vault's same audit hash function because it uses the same hash to hash the data. So if you pass the information through that audit hash function, the value of that hash will be the same. So that's what we'll see now. So I'm going to enter my information in a file called payload.json. In the payload.json, just as an example, I'll put the username of, let's say, one employee or one application. But you can do it in a script. Let's say you have 1,000 employees or 1,000 application. You can put 1,000 lines and then run through that. So now that I have the payload.json, I'll call the Vault audit hash function. I'm making curl request to my Vault server, and you can see the end result is sys audit hash Vault audit 1. Now, if you see that I'll highlight in a bit, you can see the HMAC value, the SHA, ending at 9102. This is the same value as the username we have, 9102. That means now even if you have 1,000 people or 1,000 applications running through that same audit function, you can match who is the person from that specific audit response. All right, cool. So we checked how we can do authentication using Vault, that is generate time-bound dynamic credentials, how we can do authorization, like how we can limit fine-grained access, like to the database statement level, and then how we can do auditing using Vault. But then someone still figured out my password. What do? Do you have a break glass procedure? So what's a break glass procedure? Break glass procedure, decades ago, it meant that someone actually printed out the password and put it in a physical safe. It might still be the case now that, let's say, the Vault server is down. You have the printed copies of some admin-like credentials. Maybe that credentials can't do anything, unless just it can create more users. So you put that information in a physical safe. So that is your break glass procedure. I like the saying that in the time of emergency, break glass to retrieve something. So even if you use a secret management tool, the suggestion is to have proper policies and a break glass procedure. All right, so what was the goal of this session? We spent roughly half an hour to learn about a new tool, but what's the goal? The goal is to become aware of the threat, aware of the increasing difficulty in keeping our information safe. And what hosts the information are the data services. The other goal was to inform, to give you some information that you can do your own research and then make an informed decision for you and your engineering team. So I know there's a ton of information for half an hour, but if you'd like to take a picture, this would be the slide which has all the details. So the QR code would take you to the blog. The blog includes everything, including the demo. if you like GitHub repository, I prepared a GitHub repository as well for you. It has everything that's in the blog, but what it'll have is it'll have an FAQ.md. That means if you ask me a question and I don't know the answer, rather than me asking for your email, what I'll do is I'll take that. You can either open an issue in that repository, and I can create an FAQ.md. I'll put all the information in that FAQ.md so that you can find it out in a few weeks. All right. So if you have any questions, feel free to ask them now. You can also email them. Thank you. Question, please.
Yes. You talked about time limits and authentication, but does this also automatically expire the sessions that are active when the time is up, or so that when I can't authenticate new sessions anymore, does it also expire the existing sessions for the user?
Good question. So I'll repeat the question for recording. So the question is, the PostgreSQL session, right? You're saying the session already invalidates after a certain time frame, and then we have the creation of user with this TTL. So is the question that how do you manage these both overlapping time?
No, if I authenticate the process, I only provide the password username once at some point in time, but I can keep using the session with the authentication that were provided for essentially a limited time or until the server dies.
Yeah, that's a good point. So I think what I'm highlighting with this time-bound access is not to have your database password stay forever. So that means I totally understand the point is like if I generate for a few seconds and then suddenly the credential is expired, the session is valid, and then you can't log into your services. But you as an administrator, you already know the limit of your session. So the ideal time frame or the TTL for that credential would be either same or a bit longer than that session and not a year. So that's where, because most of the long-lived credentials, especially for database, is they're just lived for a long, long time. So that's why making it for that session or slightly longer would prevent your long-lived or password that's just staying forever.
I think his point is that once the session is established, there is no expiry of the established session. That's what I think his point is.
Expiry of the session?
Yeah, you don't get disconnected, or your session doesn't automatically die with the credentials that you use.
Got it. So my credential is expired, but you can't. So that's the check with your application. So the application, if it does a periodic check, if your credential is still valid, some sort of session pool that checks if the credentials is valid and then terminate the session based on the validity of the credentials. So the application would need to take care to invalidate the session in that case.
So this is not an integrated thing involved that protects against leak potential in the time of valid credentials are valid.
Right. So your application logic would need to take care of that. That if my credential is invalid, check with the vault. If it's valid, then invalidate that database session. Yeah, I think there was a question back from.
Yeah, I think there are broadly two use cases. Okay, one use case is where you do have either services or users who need access on an ongoing basis. There may be time windows within which they're permitted access, but they still want access on an ongoing basis. There's a second case where it's kind of an on-demand access, maybe for DevOps purposes or what have you, and they need to access it only for 2 hours, or not after that, or not before that. So it looks to me that for the first case, you already have a solution for it in terms of corporate identity providers. Right? You don't need to enter password to use an Active Directory or one of the new fangled ones, for example. You still get single sign-on. You can still enforce things like you can log in only Monday through Friday, 8 to 5 or what have you. And all these problems actually automatically go away. Right? There is no actual password entry that you can enter. It looks like this is more suitable for the second one, where it's kind of a more of an on-demand one, which is quite a bit of an overhead if you go through the IDP, enterprise IDP provisioning. Is that how you see it, or you see it differently?
So one of the use cases I've seen in consulting, and it's for example, when I used to work at IBM, we used to use Vault for a lot of bank and big insurance companies. And their use case was, we have a lot of different either, as you mentioned, either Azure for Active Directory or different cloud providers, but also databases. And we don't want to manage secrets for all these different providers. So I want to use one secret management. Yes, from the Azure side, from Active Directory, you can mention that after a certain time frame, it's going to be invalid, but just the core creation of the credential for different users as well as application, they wanted a single management plane, a single source of truth for all their secrets. So that's where things like Vault come into play. And also the auditing. So who did what? Sometimes it's compliance reasons as well. So Vault provides you all the auditing as well. And it doesn't have to be Vault. The concept of dynamic credentials that it didn't exist before, now you generate that and then that expires automatically. So that's what, I think what you mentioned is right. Like the second use case is more appropriate for that. You have a question, I think. Yes, go ahead. That's a question. What I'll do is, if you could send me that question, I don't want to give a wrong answer, but I'll definitely add that question and find that answer and add it to the FAQ.md. So I'll put the link, tinyurl.com, Dewan-PGCon. If you could add an issue there, or send me an email, whichever is easy for you. I'll find that answer and add it to the, yeah, cool, yeah. Correct.
So, is there any safeguard to, like, if that is leaked, cannot generate a credential?
Good question. So you asked about the question was, we use the Vault root token to generate the dynamic credentials. So if that root token is leaked somehow, someone can just keep creating different credentials with unlimited access. What's the way to safeguard that? So I showed a demo of a development environment of Vault. In a production environment, when the Vault starts, it's sealed, and there's some number of people has to come. There's a shard. There's the different pieces of the keys. Imagine like if your key is broken, 5 pieces, all those 5 pieces has to come together in order to unlock or unseal the Vault. That's what needs to happen. Let's say your head of engineering, your CTO, and different people, they come together and unseal the Vault, and that's when you get the root token. So of course, you treat the root token just like all databases or all secret managements have a master password. It's like that master password. But once you see that token, you don't need to store that. You can create multiple credentials using that, and those lesser root token privileged access could be used to generate other credentials. And then you can seal the Vault again. Yes?
What I think I saw in your demo was that Vault was configured to create the temporary credential by issuing a create user command that was provided there. So Vault itself holds a fairly powerful credential into your database. And I think in the normal operation while your app is running, the app somehow connects to Vault and authenticates, and then Vault goes and creates that dynamic credential. What forms of authentication are you using or are available between the app and Vault in normal operation? Because it seems that being able to authenticate to Vault as the application would get you a dynamic credential.
The question was, what sort of credential or authentication exists between your application and Vault? And because Vault creates all these dynamic credentials based on that. So we configure, the applications have different integrations, which is the secret backends. But when you by application, I mean, it could be a user as well. So human user and application. So they log into Vault over HTTPS API. So whether it's UI, CLI, or the internet, you authenticate with Vault based on, let's say you have an LDAP provider. So your administrator uses that LDAP credentials to allow access to Vault. Whatever access you have from your LDAP, that's how much access you will have to Vault. So that can be linked to ACL within the Vault. So you as a human user or your application, when they logs into the Vault, they'll have a token. That token will have the same level of access, whether it's GitHub Teams, how much access you should grant on the application or services you touch. And based on that, the tokens would be created. So it will be impossible for someone with lesser access to suddenly gain access to Vault and suddenly get more access. Was that sort of the question?
That was sort of the question, but it seems to me if I'm choosing between a situation where, say I'm configuring an app and I know the operations I want this app to be allowed. Pre-Vault, I would create a credential in Postgres that had those permissions and only those permissions. And if someone obtains the credential and the password being used by the app to connect, then they can do those things. What Vault seems to be adding is one more step, where my app now uses some credential that Vault recognizes, and Vault then creates the dynamic credential with Postgres. But if someone obtains the credential that my app is using to authenticate to Vault, they can have Vault create a credential for them into Postgres and do the same operation.
Yeah, the beauty here is it's not a new way of authentication. Let's say you use GitHub Teams. You can have it a single sign-on to use Vault. So of course now the question can always go back to what if someone can still authenticate to GitHub Teams, or how, like there's no end to that question. Someone can always get the end of that. But when you're using Vault, first of all, it's not long-lived. It's depending on how much you configure Vault on the TTL. The second is the Vault has to be open, sealed in order to make that operation. So in terms of a breach, you have to shut down your entire application or your database. With Vault, you can seal the Vault and use a break glass procedure. Then you can configure Vault to have the same, you're just offloading. Previously, you had everything on your application, those, let's say, 5 statements. Now you're offloading those to Vault, but now you can do multiple of these based on permissions. So you can have one policy. So think of it as like bringing standardization to your authentication and authorization. So you can configure all these different policies, not for one application, not for one use case, but multiple use cases. And all of those could be audited as well using Vault. Great questions. Any other question? All right, cool. So I'll be here for both days. If you have any question, find me and we can chat more. And definitely that question, please send me that question and I'll definitely add that question to the FAQ.md.
One question I'd ask is,
yes.
So with Vault now in the path, let's say I have a service that's using it for the dynamic password, Vault is now in that path. If something happens with Vault, like that becomes unbreachable,
yeah.
Like what kind of contingencies are there?
Great question. So first thing you would do as an administrator is run Vault in an HA mode, high availability mode. So multiple Vault servers are running. If one Vault server is down, other Vault servers can still work. Let's say there's a huge disaster, like the whole region is down, the whole Vault server is down. Then you'd be the break glass procedure. You'd still have few database credentials, and then you'd bypass Vault to access and still keep your database services running. All good? All right, cool. Thank you everyone for joining this session.